Hello everyone. In this session, we are going to see the security provided by Linux for the files. So why should we bother? So because any unsolicited or unauthorized user can corrupt, change or remove the crucial data. So to prevent people from accessing each other's confidential files also, we need security. So Linux divides the authorization into two levels. One is by specifying the ownership, another is by specifying the permission. There are three types of ownership for a Linux file or a directory. You have a user or owner. He is the person who created the file. Other is the group. Users belonging to a group will have the same access permission to a particular file. Then you have the next owner is the other. He means everybody else. Any other user who has access to a file. He has neither created the file nor he belongs to the user group who could own the file. So you have got three types of users: user or owner, group, and others. Permissions. Similarly, you have three types of permissions defined for all the three owners. So each file and directory can have three permissions for all the three owners. So the permissions are read, write, and execute. Read permission given for a file will provide you the authority to open and read the file. Read permission on a directory allows you to list its content. Write permission on a file allows you to modify the content of a file. If the write permission is given on a directory, it allows you to add, remove, and rename the files stored in the directory. Execute on a file is the authority to run a program, an executable program. Execute on a directory allows you to move into the directory using the cd command and to access the resources inside the directory. So as we have said, you have got three types of users. One is the user owner, group, and others. There are three types of permissions: read, write, and execute. And the hyphen stands for no permission. So this is what you get when you give a ls command along with the option -l. So ls minus l will give you the read, write, execute permission of that particular file. First hyphen denotes the type of the file. Next three digits or characters specify the read, write, execute permission of the user. Next three characters specify the permission for a group, and the last three specify the permission for others. So in this example, the user can read the file, can write or edit the file. Since there is a hyphen here, he cannot execute the file. In the group, similarly, he can read. Group people can read the file, write the file, but they cannot execute that. Others, that is people who are not the owner, who are not in the group, they have only the read permission. They do not have the write permission as well as the execute permission. So, permission on a file. If it is a read permission, you can display the file, copy the file, compile the file. If it is the write permission, you are able to edit, you can rename, you can move the file to another location. Permission, execute permission on a file will allow you to execute the file. Permissions on directories. If it is the read permission, you can list the content of a directory. If it is the write permission, you can copy, remove, rename, make a subdirectory, remove a subdirectory, move files to and from the directory. If it is an execute permission on a directory, it means move into the directory using the cd command and you can access the resources there. Suppose you are given a write permission on a file, but you do not have a write permission on the directory where the file is stored. What does it mean? That means you can able to modify the file content, but you will not be able to rename the file or move or remove the file from the directory because you do not have the right permission on the directory in which the file is stored. Changing the file access permissions. The command is change mode and file name. This mode, we have got two types of mode. One is the symbolic mode, another is the absolute mode. Symbolic mode, the file permissions are represented as characters. In absolute mode, the file permissions are represented as a 3-digit octal number. So in the symbolic mode, you have to specify the user, you have to specify the permission, and you have to specify whether the permission is granted or revoked. So the users are owner, group, others, and A stands for all users. Permission, we have seen R stands for read, write, and execute. If you give plus, that means you are adding the permission. If it is hyphen, you are removing the permission. If it is equal to, you are assigning the permission. When you are assigning the permission, previous permissions are overridden. We'll see with the examples. Change mode O plus X, XY, Z dot text. This is the file name. Here O stands for others and we are adding permission, execute permission for others. UGO hyphen RWX or minus RWX. That means you are removing the read permission, write permission, execute permission from the owner, group and others. Here, change mode UG plus RW O minus X abc.text. That means you are giving read permission and write permission to the owner and the group. If both the people has got the execute permission, it will be retained. Now for others, you are removing the execute permission. UG equal to RX. That means if UG has got some other permission RWX, now I am assigning RX. That means previous permissions are overridden by this. So this owner and group will have a read permission and execute permission. Others will have only read permission. Absolute mode. Here the permissions are represented as a 3-digit octal number. If there is no permission, the corresponding octal value is 0. If you are giving an execute permission, the value is 1. If you are giving the write permission, the value is 2. Read permission, the value will be 4. Suppose you give a execute and write, then it will be 1 plus 2, that is equal to 3. Suppose you have read and execute. So 4 plus 1, 5. Read plus write will be 6. Read, write, execute will be 1 plus 2 plus 4, that is 7. Here it is written as symbolically. Absolute mode. U is equal to R, G is equal to WX, O is equal to RX. Can you just guess what will be the corresponding absolute mode? When it is R, it will be 4, W will be 2, X will be 1. So 2 plus 1, 3. Here it will be 4 plus 1, 5. So change mode 4, 3, 5. UGO plus RWX. We are giving all permissions. The R, you have 4 value. This is 2, this is 1. This is 4 plus 2 plus 1, 7, 7, 7 for owner, group and others. Suppose you have 775. That means you are giving read, write, execute permission for the owner, read, write, execute permission for the group, and you are removing the write permission here. Only the read and execute permission is given. You can also change the ownership and the group. The ownership can be changed by the command chown owner file. So here you can specify the new owner and you can list all the files here. So all the files will have a new ownership. Similarly, you can also change the group. Change group. group name, and file, list of files or the directories. Next, we are going to see an important concept called umask. So, we know that the read-write permissions can be given. But what will happen when a new file is created? So, what is the file permission for a file created now? So, this initial file permission is decided by two things. One is called a mode value, another is called a umask value. So, mode value minus umask value will be the initial file permissions. So this is the mode value, predefined initial. So for a file it will be 666, for a directory it is 777. So the mode value for a file is 666, mode value for a directory is 777. And the umask value, default value will be, it will be a 4 octal number, 0200022 for a file, and umask value for the directory will be 0002. So when I'm subtracting, I get 644 for a file and 755 for a directory. That means if a new file is created, for the owner it will have the value 6. That means read and write permission. For a group it is 4 and others it is 4. That means I am only giving a read permission for the group and others. Similarly, for a directory, a new directory is created means I'll have the read write execute permission for the owner and read and execute permission for the group, read and execute permission for the others. So where are the values stored? For the new users, this umask value will be stored in /etc profile. That means you can change the value in this script. So it is used to print or modify the umask value of files and a directory. For the existing users, you have to change .bash profile. So this command, umask command, is automatically executed when a new bash shell is created. So there are two ways of specifying the command. One is just umask, another is the umask value. Umask is to return the current umask value. Suppose this is the actual value set. Suppose you want to modify the umask value, you can specify umask and that value to be modified. So umask is return the system's umask value as a 4-digit octal number. Umask minus S will be the same thing symbolically. Umask U plus W. That means I am setting the mask so that user, that is the owner, will have the right permission when the file is created. That means I am prohibiting the execute permission from the owner, giving read permission for the group and write permission for the others. Suppose I don't specify A equal to, A stands for the owner, group and others. So if I don't specify anything, that means new files are inaccessible to anybody. A plus R means I am giving read access to all the people. U minus X, I am removing the executable permission from all the users. 777, that means it is file is inaccessible. It is the same as A equal to. Umask 000, that means you are making all the files completely accessible to absolutely everyone. We'll see an example, touch test file. This touch command will create the test file if it is not available. Suppose the test file is available, the time of modification is changed. ls minus l test file. So it gives the read write permission given for the owner, group and others. So here you can see that default value is 666 for the mode value. This is the umask value. So when I subtract 664, that means read write for the owner, read write for the group and read permission for the others. Suppose I say umask 022, I am changing that umask value. Now when I create another file, what will be the permission for that another file, test file 2? Here you can see that it will be RW, or there is no write permission here, because when you have 666 minus 022, I have got 644. So previously the UMask value is 002, so I have got 664. So based on the UMask value, new file permissions are set. Thank you.